Volantis was located on a deep ocean base on Kellingsøya in Haugesund. A small technical detail that was omitted from both me and probably the teacher is that Volantis had a standard 5-year dry docking where they had to go on a workshop in Frederikshavn in Denmark. This meant that there would be no departure for the crew of Volantis until the 3rd of January, and then the ship would only be handed over to be renovated. Volantis had to be renewed, among other things converted into a hybrid, a new DP system installed and a completely new board system dismantled and installed. This was a big workshop stay and a lot of preparation was needed. Unfortunately for me, this meant virtually no seagoing time, but that was going to be okay for me as there was a lot of work to be done and a lot to learn in the period before the ship had to be dry docked. I had previously been on board the ship Buka to Pass, also owned by Volstad, during deployment in Vega 2. The ship is almost identical internally and externally except for some machinery. The ship was first time registered in Panama and was put together by Fosen Mechanical Workshop in Norway. Volantis' IMO number is 9399533, and even though MS Volantis is not in operation from 2023 due to being in a workshop, it is actually leased for 6 years to CTC Marine Projects, which is a subsidiary of Deep Ocean ASA, which will use her for ConocoPhillips Ecofisk Life of Field Seismic Test Cable project. The work that they had done there consisted of installing and laying cables in an area of 12.6 kilometers. Then followed the work on Kittiwake, which is an oil platform outside Aberdeen, an assignment with a value of approximately 60 million krone for a decom offshore. Here work will be carried out in connection with the decommissioning of a loading buoy for tankers. Currently the ship was carrying out ROV missions with the 2100 kilowatt UT1 Ultra Trencher and a 2000 ton carousel for fiber optic cables. And the last project that Volantis was a part of was using its ROV technology to look for sabotage and bombs on gas pipes after the gas pipe leak in the Baltic Sea. The original contract with Deep Ocean has 1 year remaining but is currently inactive as all the work has been completed that they had been hired for. Propulsion is diesel-electric with 4 Mach 9M20C diesel engines, each with an output of 1530 kilowatts, and Cat 3612 TA engines, each with 3800 kilowatts. The generators are from Scandinavian Electric Systems, and 2 of them consist of 3500 kilowatts and 4 of them consist of 1450 kilowatts. The 2 propulsion propellers are of type Ulstein Aquamaster US 355 P50CP. The emergency generator is a 275 kilowatts Mitsubishi F6B type. The ship's speed is approximately 15 knots with a 5.5 meter draft. In order to achieve the best possible maneuvering characteristics, the vessel is equipped with the Kamewa Ulstein tunnel thrusters, 1 aft and 1 forward, type TT280 DPN-CP, each at 2000 kilowatts, and 2 azimuth bow thrusters type TCN SO92 CP, each at 2200 kilowatts. Deck Hydromarine has delivered an AHC offshore crane of 150 tons with 2000 meters of wire, and the auxiliary crane is from Bergen Group Dragon. The helideck has a diameter of 21 meters and is used by type Super Puma and Sikorsky N92. The rescue equipment includes 2 90-person lifeboats from Eide Marine Tech, a mob boat type Springer MP741 and Viking life rafts. As always, turn off the power to the system first, and then start by loosening the bolts and the wires to the motor. PS, make sure you switch the water off completely, because otherwise you're gonna get a leakage. After doing it properly, take the motor to the workshop to further take it apart. Here you can see the copper coils inside the motor, and a very used pair of bearings that need to be replaced. It's a relatively easy process to take apart the rest of the motor, you just have to loosen every screw that you see. And then take the rotor from within the stator and use the adequate tools to take off the bearings after. Apply some lubricant just to help the bearings come off, as they don't need any lubricant when they are put on back again. Then put the new bearings inside the Elmatherm to warm up to around 95 degrees Celsius. This motor had 2 bearings that needed to be replaced on both ends. Then put it back together and be happy with your work. There was an alarm that went off in the STP, which is the sewage system on board. Get the logout tagout order from the bridge and then turn off the fuse. Only 1 contactor had to be renewed. But that 1 contactor meant that half the bridge could not flush their toilet at certain times. Simply reconnect the wires to the functioning contactor and then test to see if it works. The contactor was worn out due to its high consumption, and then write a report in TM Master and wait for the next job. Paul and me were given a new assignment to troubleshoot the searchlights on the wheelhouse. One of the searchlights could not focus. Since the problem could be the wiring to the focus motor or the switches, we took a bypass directly from the power supply to the motor and tested again, and it didn't work then either. The engine was defective, so we removed it and put everything back in its place, and then this is what the engine looks like on the inside. It was a bit dirty and closer inspection pointed to direct water damage as the fault of the motor problem. Then it was just a matter of ordering a new one and waiting for it. The cathodic protection was easy to test. Simply turn the knob and register the readings and then send it into CAT-WELL. The cathodic protection protects the hull of the ship against deterioration. The CAT Sense is also a system on board which does this process pneumatically. This is the placement of these cathodic emitters. We were testing the UPSs, and after a quick run-through of the UPS, it showed us that one of them had under the required 20 minutes of battery time and too low capacity to be used in emergencies. We had to replace the batteries and order new ones and wait for them to arrive. First, get the lockout-tagout order from the bridge, which must be signed. Locate the capacitors, and when located, remove the panels for easier access. Always be sure to make an extra voltage measurement just to be sure. Remove the connections between the faces of the capacitor and then measure between the faces on the millifarad function on the multimeter. Each capacitor should have at least 47 millifarad. When all the measurements are approved, then put everything back into place and fill out the completed work order. An error message appeared on the UV sterilizer. This is because it needed to be cleaned. The UV sterilizer cleans the water on board and disinfects it. You have to remove the light from the inside of the system and then wash the pipe. As the ETO shows here, it's quite dirty. Then clean the filter as well and test the system. Green means good. This time it was a big boy that needed to be overhauled and a light that needed to be changed. Use the documentation to find the wire, and from the wire find the cabinet and then find the fuse connected to the electric motor. Multitask and change the light as well. Then get the fancy logout tagout order from the bridge. This was number 100 of the year, which seems to be very little in my opinion. Then when approved, turn off the power to the motor. Then practice work safety and always measure to be safe. Then start disconnecting bolts and taking everything apart, and when the wires are disconnected, put the bolts back so that you don't get ingression. Since this was such a heavy boy, you have to use the block chain to lift the electric motor and pull it sideways to rest on a bench or on the ground. Keep practicing workplace safety and wear gloves. Don't be like me. After a few tears and a few kisses from the ETO, continue with the work. Measure how deep the rotor has to go so that you know exactly how to put it back. And remove all the parts leading to the bearing, and then use the specialized tools to loosen the bearing itself also. After it's loosened, find the correct bearing in the storage and then warm it up to make it ready. When it's warm, then you can bang that baby back into place and then you can start on the other side. Since I put it back together, I don't have any footage, but this is basically the same process. As always, get the lockout tagout from the bridge. Give that baby a few spins to take off the power. Really make sure to spin it all the way from connected to disconnected. Acknowledge the alarm so that the ship doesn't panic and think they're sinking. Always safety measure so that you don't die instantly when you touch it. Loosen the cables because there is a small electronics that can be destroyed by the test. Desired measurement is 2.2 megaohm. And when you are measuring something like this, it should never be under. When the measurements are done, then you have to put everything back together and use a special tool that limits the amount of force that you apply so you don't destroy everything because the copper is pretty sensitive. The next measurement didn't need to disconnect any wires because they were part of an open circuit. Lots of capacity in the wires, so pretty wild measurement, but approved. And then just fill out the work order as always. Christmas rolled around and the mess crew had prepared a feast of grand proportions. Here you can see the deck crew with captain, chief officer and the first officer from left to right. And then after dinner we did a series of games. This one was particularly confusing but funny. It involved trying to hit a piece of candy with a courgette tied around your waist across the room. And other various weird activities. Here you can see the crane operators in their full glory. And this was my very modest serving of food. After Christmas, the chief engineer wanted to spend some alone time with the engine crew, so we spent some time together in his cabin and then went out to be social. It was a rather unique experience, but very fun nonetheless. After that, it was time to sail out to Frederikshavn, and weather reports indicated that it was going to be a bumpy ride. I was quite sick and didn't get to video the wild seas because even standing cost me almost all of my energy, but after a nap I felt much better and was told I handled the rough seas very well for my first time. Then we had a fire drill with instructions from the chief officer, and New Year's rolled around again with various fun and similar celebration as Christmas. It was one of my favorite Christmases and New Year's, definitely happy to have been there even though I miss my family. Once we came to Frederikshavn, it was time to commence the dry docking. I will take you to the whole process before dry docking can be commenced from the electrician's side. What was going to happen now was that the ship had to black out before making the shore connection. First, you have to turn off the cathodic protection or the hull protection or ICCP, and this is because the ship is no longer submerged and doesn't need it, as well as that it poses a danger to those who are maintaining the hull. Then turn off the standby of the emergency generator because it must not activate once we are blacked out. And then I got the rather rare honor from the chief to black out the ship by switching off the last generator. Now only equipment protected by the UPS was still on and shore connection was about to take over. All those alarms, luckily we weren't on sea. Then shore connection was established and the shipyard wanted to go through the crane cables and not the actual shore connection because they needed 690 volts and the shore connection was set up to only 440 volts. Because I was busy with the other process, I wasn't there to observe the shore connection, but that work was performed by the shore electricians on the dock anyway and not the ETO. Then we needed to lock out all the thrusters and all the equipment that wasn't going to be used and walk up and down the stairs to the bridge to get the log-out tag-out for each and every one of them. I got some serious leg gains from this trip. And then when the ship was fully dry docked, we went for a peek under the hull. It was insanely huge and a very cool experience to observe. Here are the main thrusters of Volantis and the tunnel thrusters, and the hull protection. Observe the condition around the electrode. And here you have the navigation buoy. And once again, just seeing this giant underbelly was pretty awesome. Then upon returning to the ship, a non-planned blackout occurred. Too much equipment was being utilized and caused the breaker to switch. It was told that it was a maximum load of 900 ampere and it was long over. The chief turned on the emergency generator and after around 5 minutes the power was back. And then naturally I had to sprint up to the Monkey Island to turn off the emergency generator. After that, me and the ETO had to look around for equipment that was destroyed by the blackout process. And then I found this thing. I'll see you in my nightmares, Mr. Ropehead. Another measurement for the capacitors, this time for the frequency converter on thruster number 5 and 6. These are the main thrusters on the aft of the ship. Dismantle the connection between the capacitors and start measuring in microfarad. This measurement is too low. Our readings were too low as each capacitor needed to have 47 microfarad. Most were too low and even some were completely zero. The zero one had to be replaced, so find it in the inventory and then locate it in the location in the ship. Test it to make sure it's okay. This one is over 47. Replace it, which wasn't the easy task. Then fasten everything, measure again and make sure everything is over 47 microfarad per capacitor. Close everything up and clean your workplace and then report all of the measurements in TM Master. We needed to lock out all of the switchboards connected to busbar 2 because of the Oskov yard people and they were going to completely replace it. We carefully isolated all of the equipment that no longer needed to be used and created bypasses to the ones to make this work. Unfortunately, the ship blacked out, and again, and once more. Until finally it was done right. Then one of the alarms notified that the sewage system was offline. Panic and mayhem as people couldn't flush their toilets. Honestly, this stresses people the hell out. So me and the ETO had to create a bypass directly from the power on the sewage system to the nearest 440 volt system, since everything in the purifier room was 690 volts. This took some work, but finally we pulled the cable to the cabinet and created a bypass to make the sewage work again. Unfortunately then, the wiring was incorrect and hopefully nobody flushed their toilets because they would operate more like a volcano than a vacuum. Once corrected, the system was working again and peace was established. Then we had to get around 16 log-out tag-outs for the entire right side of the switchboard room and then organize them neatly with the newly marked locks. One of the motormen was in a confined space, so I had to make watch and make sure he doesn't pass out. I had to do oxygen tests and report everything to the bridge so that they know. It's not the most exciting job, but a lot of people die in tanks, so it's an important one. Look at this guy go. To celebrate the end of the shift and Martin the DPO his birthday, we went and had dinner all together and socialized with live music. It was definitely a great time and I was very happy to have been with this crew. Here you see the crane operator having the time of his life. I spent the majority of the final time writing a handover which I would use for school and also to help Pavel who had limited English. Then one of the yard workers set off one of the call points by accident and we had to replace it. Simple process, program the new call point, find out which number on the diagram, replace it and use this key to arm it and voila. Important to communicate with the bridge and tell them so that they can acknowledge the alarms. You don't need to think about connecting any wires, you just have to floop it in. Then I got another tour of the outside of the ship, this time the bow, and even going under the ship, which was a pretty weird experience, and seeing where the swing-up thrusters used to be. And here are the aft thrusters in maintenance. And then the end got close. The last days we didn't have much projects, mostly because me and the ETO had finished almost everything we could from the assignment list on TM Master. We were social with the crew, had conversation and had grown fond of each other. And it was time to say goodbye. A big thanks to Volstad for giving me the opportunity for being with them, and the ETO for being a great teacher who never got tired of me asking a ton of questions and always making sure to include me in the work, as well as the chief for welcoming me and making me feel like a part of the crew. I hope our paths cross again sometime in the future.